Arithmetic, Boolean, and logic operators. In this video, we will learn all of the arithmetic, Boolean, and logic operators and what each of them do. Starting with arithmetic operators. Arithmetic operators form arithmetic expressions, which return numeric values. In this course, we'll learn about four of them. The first of them being the plus operator, which adds A and B together. Then there's the minus operator, which subtracts B from A. Then there's the multiplication operator, which multiplies A and B. And then there's the division operator, which divides A by B. In this course, we'll also study a couple of numeric procedures, which are procedures that perform a sequence of arithmetic operations to compute a numeric value. The first one is the mod procedure, which computes the remainder when A is divided by B. For example, when you divide 4 by 2, you get a remainder of 0 because 2 divides 4 evenly. When you divide 5 by 2, you get a remainder of 1 because 5 is an odd number. When you divide 12 by 5, you get a remainder of 2 because that's how much is left over when you divide 12 by 5. Next is the random procedure, which generates a random number between A and B inclusive. For example, if 1 and 3 are our inputs to the random method, then we could either get 1 back, 2 back, or 3. All three of those values have an equal probability of being returned. Next, Boolean operators. Boolean operators form Boolean expressions, also known as conditions, and they return either true or false. Okay. The first Boolean operator is the equal operator, which returns true if A is equal to B. For example, the expression 3 equals 3 evaluates to true because those two numbers are in fact equal. However, the expression 2 equals 4 evaluates to false because 2 and 4 obviously are not equal. The next operator, the not equal operator. This operator returns true if A is not equal to B. For example, the expression 3 does not equal 3 evaluates to false because 3 does in fact equal 3. On the other hand, the expression 2 not equals 4 evaluates to true because 2 does in fact not equal 4. Next, the greater than operator. This operator returns true if A is greater than B. For example, the expression 5 is greater than 3 evaluates to true because that's a true statement, whereas the expression 3 is greater than 5 evaluates to false because that is not a true expression. That is a false expression. Next is the greater than or equal to operator, which returns true if A is greater than or equal to B. For example, 8 is greater than or equal to 5 evaluates to true because that's a true statement. 5 is greater than or equal to 5 evaluates to true because that is also a true statement. However, the expression 3 is greater than or equal to 5 evaluates to false because that is not a true expression. Next, A is less than B. This returns true if A is less than B. For example, the expression 3 is less than 5 evaluates to true because that is a true expression. However, the expression 5 is less than 3 evaluates to false because that is not a true expression. That is a false expression. Then lastly, the less than or equal to operator, which returns true if A is less than or equal to B. For example, the expression 5 is less than or equal to 8 is true because 5 is in fact less than 8. The expression 8 is less than or equal to 8 also evaluates to true because 8 is equal to 8. However, the expression 10 is less than or equal to 8 evaluates to false because that is a false expression. 10 is not less than or equal to 8. Lastly, we have the logic operators, which form logical expressions. Their operands are conditions, and they return either true or false. The first one being the not operator. The not operator receives just one operand, and it returns true if the operand is false, and returns false if the operand is true. For example, if we attach not to the expression 1 is less than 2, since 1 is in fact less than 2, attaching not to the expression would make the expression false. Whereas if we attach not to the expression 1 is greater than 2, since 1 is not greater than 2, attaching not to that expression would make the entire expression true. Next is the AND operator, which returns true if both A and B are true and returns false otherwise. For example, in the first line, both the left and the right conditions are true statements. Thus, the entire logical expression evaluates to true. However, in the second example, only the left expression is true, while the right expression is false. Since AND requires both operands to be true, in order for the entire expression to be true, the second line, the second example, will evaluate to false. Likewise, in the third example, both the left and the right operands are false. Since AND requires both operands to be true, the entire AND logical expression will evaluate to false. The last logical operator is the OR operator, which returns true if either A or B are true and returns false otherwise. In other words, the OR operator needs just one of the operands to be true, at least one. For example, in the first line, both the left and the right operands are true, thus the entire OR expression becomes true. In the second example, only the left operand is a true expression. However, OR only requires one to be true, so the entire OR expression evaluates to true. In the third example, both the left and the right operands are false expressions. Since neither of them are true, the entire OR expression becomes false. We can also depict the behavior of logical operators with a truth table. A truth table is a table that shows how the truth or falsity of a logical operator changes as its operand changes. To show you what I mean, we'll start with the truth table for the AND operator. When both A and B are true, the expression A and B evaluates to true because both operands are true. If A is true and B is false, then the expression A and B becomes false because, once again, AND needs both operands to be true. Likewise, if A is false and B is true, then A and B will be false because only one of the operands is true. And of course, if both A and B are false, then A and B will be false because, once again, the AND operator requires both operands to be true. This table shows every possible combination of true and false operands that could be given to the AND operator. Now let's construct a truth table for the OR operator. When using the OR operator, if A and B are both true, then the expression A or B will evaluate to true because the OR operator just needs at least one operand to be true. Similarly, if the operand A is true and B is false, then the expression A or B will be true because at least one operand is true. Likewise, if A is false and B is true, then the expression A or B will evaluate to true because at least one of the operands are true. However, if both A is false and B is false, then the expression A or B will evaluate to false because neither of the operands are true. And then lastly, the NOT operator. As mentioned earlier, the NOT operator receives just one operand. If that operand is true, then attaching NOT to that operand will make it false. Likewise, if the operand is false, then attaching NOT to it makes it true. NOT inverts the operand.